Okay, today we're going to do 9.2, simplifying square roots. There are 3 rules to follow that you just wrote down in your notes about simplifying square roots. Now when we say simplify square roots, like I said, that doesn't mean put 27 on your calculator, hit the square root button, and then write a decimal. That's if they want it in decimal form. If they say round it to the nearest hundredth, or round it to the nearest tenth, or the nearest integer. Today we are simplifying radical expressions, but you cannot have any decimal answers. When it says that we want it in a radical expression is in simplest form when it has to have these 3 things. No factor of the expression under the radical sign, remember this is the radical sign, has any perfect square factors other than 1. Number 2, there are no fractions under the radical sign. And number 3, there are no radical signs in the denominator of any fraction. And those will all make sense in a minute. Okay, maybe 2 minutes. Right here. Those are a couple examples, but let's go right to example number 1. There's actually 2 ways that you can do this. You have, say we have the square root of 150. Put that in on your calculator. Is that a perfect square? 150. Is it perfect? No. But we cannot leave it in decimal form. We want to simplify. But they say the square root is 12.247. Well, what is 12 times 12? Clear your calculator. What is 12 times 12? We should have had that memorized. What is it? Nice. 144. Well, is that not close to 150 when we hit that on our calculator? So if I rewrite this as the square root of, this could be 12 times 12. Can I do that? That's 144. Can I take it times anything else to get 150? Yes or no? No. All right. So let's go back here. Let's think of a perfect square then that could go into 150. Start with like the 2's. 2 times 2 is 4. Is 4 times anything 150? How about 3 times 3? 9. Is 9, does 9 go into 150? Get your calculators going out. 150 divided by 9, does that work? 150 divided by 4, did that work? How about then 4 times 4 is 16? Does 16 go into 150? No? Yes? No? No? Well, let's try 5 times 5. That's 25. Does 25 go into 150? Yes. So we can rewrite this as 25 times what? How many times does 25 go into 150? 6. So 25 times 6, well, that equals 150. When you have 2 of them, when we broke the factors down, that's the same as we could write it like this. The square root of 25 times the square root of 6. Now, which one's perfect? The 25 is. What is the square root of 25? So we have 5 here. Is 6 a perfect square? No. So we have 5 times the square root of 6. Final answer. Because the only factors of 6 now are 2, 3, and 6. Are either one of those perfect squares? No. So that's simplified as far as we can. So that's one way to do it, is to find the greatest perfect square factor. How many like that way? Yeah. How many don't like that way? Yeah. Okay. If you don't like that way, here's another way you can figure it out. And the thing of it is, a lot of people tend to like this one later on. after you get to know your square roots a little bit better, your perfect squares, which ones are perfect squares, and dividing by that. But if you're not comfortable, there's another way you can do it. You take your 150, and we all know how to do these, don't we? What's that called? Tree. Factor. Tree. Factor tree. So I can break down all my factors. What times what is 150? We could start out with what? We could go 2 times 75, or we can go 3 times 50, or we could go 15 times 10. And we'd all end up with the same answer at the bottom. So let's just start out with 15 times 10. Break this down to, can't hear you. 5 times 3, are those prime now? So that one's done. So the best thing to do is to circle them, because we know those are done. Now we got to break down the 10 to 2 times 5, or 2 and 5 prime. Good. So now we've got our prime factorization. So we can take the square root of all those factors. And I like to put them in order from least to greatest. So I have a 2, a 3, a 5, and a 5, right? And they're all multiplying down here when they're prime factorization. So put a times sign between all of them. Now, do I have any doubles?
Yeah.
What? My 5s right here, I have 2 of them. So 5 times 5 is 25. That's a perfect square then. So I can break, there's doubles, so I can take the 5 out. Can I take anything else out? Nope, there's no doubles. I have a 2 and a 3, so they kind of, what I like to say, they stay in jail. This perfect, these doubles, this perfect square gets to break out. If you're perfect, you get out of jail. Now, I can't just leave it like that. I can't leave it 5 times the square root of 2 times 3. My final answer will be 5 times the square root of what? 6. We simplified. 2 times 3 is 6. See how we end up with the same answers either way we do it? How many of you think you're going to like this way better? Maybe 2 of you right now? How many of you like this way better than the rest of you? Okay? Let's practice some more. Now we get to throw a letter in there, same thing. So let's do the number first. Let's do the number first. I guess I don't need the calculator here. So the square root of 18. What if I factor, if I do factor tree for 18, let's go what? 9 times 2. Circle my 2, that's prime. Break that down to what?
3 times 3.
Excellent. 3 times 3. Those are prime. So now, under my square root sign, or in my jail here, so to say, I have a 2 times a 3 times a 3. 1, 2, 3 numbers. Just make sure if you're going to do it this way, you don't leave out any numbers. That'll hurt you in the long run. You'll get the wrong answers, obviously. But now we have this t squared. T squared is the same as what? T times what? 2?
2 times
2 times t?
3. T times t.
Ah, t times t is t squared. Now I can break out of jail. Do I have any doubles? Do the numbers first. Do I have any number doubles?
3.
3 and 3. So what do I bring out?
9.
Do I bring out a 9?
3.
I just bring out a 3, right? Because what is 3 times 3? 9. What's the square root of 9? 3. All right. Any other doubles? No, we only have 2 left. But how about for the variables? T. So t squared, I can bring out a t. So what is 3 times t? 3t. Do I write a time sign between it? No. Good answer. So I have 3t times the square root of what's still in jail? What's not perfect? Only my 2 is left in here. That is not perfect. So there is my simplified radical form. Now, if you're getting better at it, you look at the 18 and go, 2 times 9 is 18 right away. You see right here, 2 times 9. Well, wait a minute. 9 is a perfect square, so I could just go the square root of 9 times 2 times t if you wanted to write it out. And I could go, hey, I know this 9 is a perfect square. I'm going to bring out 3. And, oh, 2 t's, I can bring out a t. So see how you can go 3t times the square root of 2. You end up with the same answer. Questions on that so far? Yeah.
So if there's a double number that's like in jail, you wouldn't multiply that?
If there was, say there was a 7 in here, then we would have to take 2 times the 7 that was left in
But
there.
you wouldn't take 3 times 3 and bring it out as 9?
Nope. Nope, because it's in the radical sign. So what is 3 times 3? That is 9. What is still in the radical sign? What's the square root of 9? We bring out the 3. Okay? Good questions? Any others? Let's practice. All right. 75. 75 is pretty easy. Can you think of a perfect square that goes into 75? Really? Come on, I know you can do it. It's early, you can do it.
5.
Okay, 5 times 15, but is either 5 or 15 perfect? No? Can we think of anything else? 25 and 3. 25 times 3. Oh, what's perfect? Oh, 25, you're so perfect. All right? So you cross that out and bring out a what? A 5. Is 3 perfect? Can it be broken down anymore? No. So we have 5 times the square root of 3. Now, if you did the factor tree, 75. A lot of people are going to do what when you start with 75? Take 5 into it. 5 times what? 5 times 15. Okay, the 5 is prime. And then I can break this down to 3 times 5. And those are prime. So now I would put those all in my radical sign, and I'd have 3 times 5 times 5. When I have it all broke down, do I have any doubles? What are the doubles? The 5s. So what do I bring out? 5 or 25? 5. When you have doubles, you just cross out doubles, bring it up. Because 5 times 5 is 25. The square root is 5. And you end up with 5 times the square root of 3. Exactly the same as what we got right here. Now let's vote again. On the easy ones, who likes to do this one? Oh, a couple more hands now. How about still like the factoring? Still quite a few, and that's okay. You'll learn to use both, and like I said, when you find the easier ones, it'll start making more sense, and you'll kind of go back and forth. All right, 80. Should we do the factor tree on the 80?
No, I have a question.
You have a question. Questions are good.
Okay, so for the other one that we did before the factor tree,
Yeah?
I did 8 times 10, so they're like both perfect.
Oh, you're on the 80 though?
Yeah.
Okay, let's clear this. So you did 8 times 10.
But I did it the other way. I did it where, like, you just drew, like, there's an 8 times a 10 in there. And then,
Okay.
like,
8 times
Yeah.
10, but they're not perfect squares.
because it doesn't.
You hit 8 on your calculator.
Oh, okay. Now I see.
You hit 8. It's not perfect. Sorry, 8, you're not perfect. How about 10? Oh, sorry, 10. Even though they say you're a perfect 10, you're not. 10 is not perfect. So those wouldn't work. We'd still have to break it down to 2 times 4. And my 2 is now done. And this one is 2 times 5. This 2 is done. Is the 5 done?
Yeah.
Okay, but I still got to break the 4 down. There we go. Now, put them in order from least to greatest. 1, 2, 3, 4 2s. And a, what? 5. Nice. And I didn't forget anything, right? Any doubles? I have a pair of 2s, so I bring out a 2. Oh, sweet. What's this? Another set of 2. So bring out another 2. So does that mean I have 22 out here?
No.
No. That means I have 2 times 2. Can I break anything else out of the radical jail? No. All right, so I still have my 5 left in radical jail because 5 hasn't been perfect. It has to stay. So 2 times 2 is? I have 4 times the square root of 5 is my answer. So what does this tell me? If I have a 4 out here, what's 4 times 4? 16. Does 16 go into 80? How many times? 5 times, right? So 16 times 5 is how we could have broke it down if we did the greatest perfect square, because square root of 16 is 4. You would end up with 4 times the square root of 5 again. See how it works both ways? You can reverse it. All right, number 3. Want to do square roots, or the greatest square root, or do you want to do factor tree? The easy one. That depends upon who you ask which one's easy. All right, let's do this then. What do you want to start with? Actually, I'm going to erase that. Okay, what do you want to start with?
6 times 4.
6 times 4 is what I heard first. So 2 times 3, those are prime, I'm done. The 4 is 2 times 2, good. All right, now I've got 3 2's and a 3. Is that all I need to put in there? Am I done? No, brilliant. What do I have to put in there? We can't forget our lonely variables up here, r squared. That means I have 2 r's, r times an r. All right, let's cross out any doubles. I bring out a 2. That's 2 times 2 is 4. Square root of 4 is 2. Bring out a 2. And bring out the r. So on the outside, I have 2r times the square root of what? 3? 6. Who says 3? Good. I don't throw anything at anybody. Good job. Who says 6? Excellent. All 2 of you. Woo! Who says 6? There, that's better. All right. So this tells me what was the perfect square that went into 20 or 24 then if I have the 2 out here. What's 2 times 2? So if I had to take this to put it back into jail, 2 times 2 to put it back in here would have been a 4, right? Our 4 was our perfect square to bring out. That's how if we would have broken it down up here, it would have been 4 times 6. Break out the 4. The last one, number 4. Can we think of a perfect square? All right, let's do the factors then. What times what? 56. 7 times 8? And if you're not sure, you always know it's an even number. You could always start with a 2, right? But I hear 7 times 8. Well, 7's prime. Let's break that 8 down to 2 times 4. Now my 2 is done. Break the 4 down to 2 times 2. There we go. So everybody together, tell me what's in my jail from least to greatest. In my radical jail I have 2 times how many 2's? 3. 1, 2, 3 times my 7. Done? No. What did I forget? What did I forget?
The m.
Yes, my variable. So I need times m times m. I'm squish them in there. M&M's. Hey, what breaks out of jail? A 2 and an m. Can I write this? Can I write this m2 times the square root of what's left inside here? 14, because you multiply what's left. Can I write this m2 like that? No. No, it's always the number first and your variable. That looks like we're in 2nd grade when we write it like that. 2m times the square root of 14, and that is our final answer. Now we get to do the division part of it.
So much.
Yay.
It's the same thing. It's basically the same thing. And you're going to like these because the bottom part of it is always perfect. Your denominator, when we're just learning how to do these, your denominator is always so perfect. You won't have any where your denominator is not. You will learn that, however, next year in Algebra 1. All right, so here we have a fraction inside of a square root. Well, I could turn it into a decimal, but that's not going to do me any good. I could go the square root of whatever 17 divided by 25 is, and then hit my square root button. Let's practice that in case they said you were rounding it to the nearest tenth, which we won't, but let's just say, what is 17 divided by 25? That equals 0.68. Now we need the square root of that yet. Hit your square root button. That would be our answer. Rounded to the nearest tenth, we would have point what? 8. That's if they were asking for your answer in the nearest tenth. Or what if it was to the nearest integer? What would your answer be? 1. All right, but we are simplifying it in radical form. So therefore, I just take that fraction and I just rewrite it. And I put the 17, my numerator, right? 17 on top, my 25 on the bottom. I just take my fraction and instead of 1 radical sign, I just put 2. There, because they're each a square root. And now we do what we've learned. See, I've got my 17 on the top and the square root of 25 on the bottom. And like I promised, your denominator is always perfect. What is the square root of that perfect 25? 5. So it's not the, do I write it like this, the square root of 5 there? No, do not do that. That's the biggest mistake in the past. People break it out of jail and then still leave it out of jail. He got ripped off. He was perfect. Let him out. He doesn't get the jail sign. He doesn't get that radical sign. Because that was one of our rules. You cannot have a radical sign in the denominator. All right, so if at any time you have a square root, the radical sign in your denominator, it's going to be wrong. You can't have that. And now the square root of 17. Can I break that down at all? What is 17? Is it perfect?
No.
Nope, sorry 17, you're not perfect. I do not put a decimal up there. And isn't 17, what do we call 17? What kind of number? Prime. So the only factors it has is 1 and 17. Can I break anything out of jail? No, 17, sorry, you have to stay. We cannot simplify the square root of 17 anymore. So that would be our final answer, right there. The only part I could simplify was the denominator, right there. Questions? We're good? So far? Questions are good. All right, well, maybe you'll have some after we practice. So, rewrite that. How do I rewrite it? How do I rewrite it? Come on, how do I rewrite it?
You write the radical sign both on the numerator and the denominator.
Yes, thank you. So I have the square root of 5 over what? Yes, you're waking up. Thank you. The square root of 9. Oh, I love perfect denominators. So I'm going to do my denominator first because it's so easy. 9 is perfect. What do I put here? 3 without a radical. And then 5. Is it perfect?
No.
But it is prime, so can I even break it down anymore? No. So we just leave it, but do not just write 5 up here. Don't make that mistake.
You have to write radical.
Yeah, you still have to have the radical sign, the square root of 5 over 3. Done.
Is that easy?
Some of them, yeah. All right, now, number 6. The square root of 21 over the square root of 64. Who wants to come up here and write the answer for this one? Go for it. What do you get? The square root of 21 over 8. He's got written up here. The square root of 21 over 8. Yay or nay? Good. Is 21 prime? No. 21's not prime. What are 21's factors? Oh, if we were to do a factor tree. 3 times 7? Oh, but there's no doubles. I can't break it out either, can I? So is he correct? Yay! Excellent. You get an A. Nice job. Who wants to do number 7? We have the square root of 16z over, I like to change the colors, the square root of 49. Ooh, look at everybody. Who wants to do it? All right, come on up.
I'm just asking.
Oh, question. Questions are good.
Is 16 perfect?
Oh, it is. Good catch.
Wait.
Ah, she asked, isn't 16 perfect? Why, yes, you are 16. You are perfect. So apply your knowledge. Who wants to come up and do it? What do you get? All right. Let's see. Do we have any debates? Agree or disagree? Everybody? Agree or disagree? So we know the denominator, because I've already told you they're all going to be perfect. So we know she's got right the 7, right? Is that 7 correct? Yay, the 7 is correct. Okay, now, out of our radical sign, like she asked, isn't 16 perfect? Why, yes, you are 16. You're perfect. So who gets to come out? A 4. Oh, my. Z, were you perfect? Is Z perfect?
No.
Z's not perfect. It's not a perfect square. It doesn't have the squared sign there. It's only one Z in there. So does Z get to come out of jail in that case? And oh, sorry, Z, you're back in jail. If that was Z squared, then we could, because that would have been like Z times Z. That would have been a double. We could have broke it out. So excellent. Nice job. So we have 4, oops, not the eraser. 4 times the square root of Z over 7. All right, now with that knowledge, let's do number 8. We have, I'm going to write it over here so we have more room. The square root of 32y squared over the square root of 81. What does that equal? Come on, who's going to be a sport? Yeah? Your hand's halfway up. Come on, you can do it. I think I can. Who wants to do it?
A little bit.
Yeah or nay?
Yeah.
All right. Yeah, you can bring your packet with. Okay, so you have 32y over 9. You mean y or y squared?
Oh, I forgot.
Okay, we'll put a squared there. Okay, I'll take it now from there. Thank you. So far, is she right? So far, would you agree? Notice I'm saying so far. The denominator is a 9. That's a perfect square. That's good. So we know, I'm going to rewrite over here again. We know that we're done with the bottom. It's a 9. How about the top? Is 32 prime? No. Is it perfect? Oh, poor 32 is not perfect. But let's do the factor tree, or do you want to do the greatest square root? What's the greatest square root in it? 2 times 2 is 4.
Oh, 16.
16. Ooh. Okay, so it would be what? 16 times 2. And this is times y, right? 16, you are perfect. You get out, what do we bring out? A 4. And, oh, we have 2y, so we bring that out. So now what do I have left on the top? Let's rewrite it nice and neat. I have 4y times the square root of, what's left in here? The 2? There we have it. Now if you would have done the 32 factor tree, we would have done what? 2 times 16. Well, you could have stopped there and went, hey, 16 is prime. Or not prime, perfect. So we got the 2. Break this down to 4 times 4. Wow, then we would have had 2, 2, 2, 2. So we've got 1, 2, 3, 4, 5 2's that would have been in the square or root or radical sign. 1, 2, 3, 4, 5, and then we have our 2 y's. Bump, 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 bump. Take out pairs, what do I have? A pair of 2's, so bring out a 2. Another pair of 2's, bring out a 2, we're multiplying. And bring out the y. And I have a 2 left inside. So 2 times 2 is 4y times the square root of 2. We end up with the same answer on the top, and then it's still over 9. So now let's revote. How many are getting it in like this way better, where we just do the 16? The greatest perfect square. A few more hands. How many still like this? And that's okay too. Use whatever you need to do to get the right answer that you're comfortable with. All right, we're going to skip through this for today and go right to the assignment, which isn't too long. It's page 460, 9 through 20, and then I want you to do 23 through 26. Make sure you check your odds in the back of the book to help you out.